In this video tutorial, we're going to be taking a look at understanding power supplies for LED signs. Now, I am working inside CorelDRAW, and I've created a tool for us when we're doing our LED sign layouts to help us calculate some of the things that we have to calculate as we're making LED signs. So here I've created a sign using CorelDRAW, and I've sized my sign to the appropriate dimension that I think I want, which is roughly 24 inches wide. Um, this happens to be for my little girl's room, and so of course the first thing that we need to figure out is how many feet of LED material we'll need for this sign. So let me go ahead and open up the My NeonFlex helper. Now, just real quickly, I want to tell you that this macro is available at myneonflex.com, and the macro is $39.99, and this is kind of the first iteration of this particular macro, so you will get all of the updates until we release the official version. But if you just want to start using it right now, you certainly can. It has some really useful features if you're doing quite a few LED signs. It's well worth the investment in time savings. Additionally to the macro, you also get 50 pre-configured uh, designs already, LED signs already made for you. So with that said, the main function of this little tool is to calculate how much LED material we need. So we'll click on Calculate Lengths, and you can see here that we need 12.5 feet of material for this particular design. And of course, the next thing that we have to know is how long each one of these segments are. Now, if you were to uh, create this design, you would take your LED string and you would just measure it and cut it, and then you would shape it around the A. You would measure it and cut it and do all of that. Well, we have it already set up where it's so much easier. So we're going to choose the output design, and we'll click on Calculate Lengths, and it will actually tell you and number uh, what each segment requires in terms of length, and of course your total footage required. So that will save you some time. You could just go through, cut all your lengths, and then you'll know exactly where all your lengths go. But what I want this to do is I want this to be able to calculate what we're going to need for a power supply as well. And so that's what we're really going to focus here on this particular video is first of all, we have to, in order for us to program the function and feature inside our little helper here, we have to understand what all the calculations are. Okay, so if you don't have the macro, and this is something you want to be able to figure out pretty easily, we can do that for you. Let's go back over here to our calculate power supply. Now, I have this PDF file available that I'm going to show you. I have this PDF file available to you as a free download. If you go to myneonflex.com and you go into the store and just click on free downloads, there's LED sign layouts that you can download and use straight away. There's LED fonts that we've created for you that you can use for your LED sign layouts, and we have this PDF file with all the appropriate calculations for you, so you'll know how to calculate what you require for a power adapter. Okay. So with all that said, let's take a look at a couple of images first of all. So we're going to come over here. Now these are two packages of LED lights that I have, and we can see here we're using 612 LED, and it says power is 10 watts per meter. Okay, so that's one thing to kind of keep in mind, that this particular pack requires 10 watts of power per meter. Now, most of your LED lights that you buy, it should tell you what the power rating is, power requirements, because it's really important. obviously. So in this particular case, it requires 10 watts per meter. Okay, so we're just kind of put that in the back of our mind. Now, if you don't understand uh, how that translates to feet, it's not typical because we don't use meters here in America. So the way to calculate that, it's 3.28 feet per meter. Okay, so that's just kind of, again, something to kind of just keep in the back of your mind, because that's going to be important here momentarily. Okay, so now if we look at this one, you can see what it says. It says the voltage is 12 volts, and I should point out too, back over here, that is important. It is 12 volts as well. Typically, you'll see 5 volt, 12 volt, 24 volt LED strips. Those are probably your three most common. So back over here, you can see we are using 612, so the same size LED strip, and it is 12 volts. You can see that there. And let's see, yes, it tells us the power rating right here is 8 to 10 watts per meter. So for safe figuring, we're just going to say, okay, it's 10 watts per meter. Now, this LED is $25, and I will link to all of these products that I'm about to show you. I will link to them in the listing description if you want to check these out for yourself. This LED is $25, and this one is $17, and it comes with a power adapter. Now this one came with a bunch of clips and some jumper wires, and the reason that I bought this initially was primarily because this one you can cut roughly about every 3/8 of an inch. And so that's pretty good when you're making signs, whereas this one, you can cut it at about every 1 inch. Now, you think, well, that I could see where the 3/8 inch, being able to cut it every 3/8 of an inch would be better. Well, when we get into actually manufacturing the sign, um, you'll discover pretty quickly that extra ability to have the ability to cut it in shorter lengths that way is actually, in practicality, really not that important, surprisingly. So while they claim it to be a feature, when you're creating LED signs, I don't think it's really that much of a feature. So when we actually get into producing LED signs, I'll explain that more in detail. But here we're really focusing on the power adapter requirements. All right, so um, so anyhow, those are the two options. So this one does not have a power adapter, so you would have to buy a power adapter, where this one does come with a power adapter. I will say this, the pink is very different on these two products. Even though the images they use on the backside are nearly identical, as you can see, these are in fact not the same. This one here with the power adapter, and again, I will link to all this in the description below so you can check these out. This is a $17 one, has the power adapter, and it is just a touch, not by much, but it is just a touch more flexible. So if you have sharp curves, small pieces that you have to curve, this one is just a touch more flexible. You could tell it's a touch more flexible, but just barely. Really just barely. All right. So let's take a look at some power adapters. So let's look. That's kind of our next thing here. I don't know if you could see this all that well, but if you're out and about and you're looking for power adapters, you have to know, of course, what what your LED strip requires. And so in this case, you can see this power adapter. This is from another RGB. This is from an RGB LED strip. Its output is 24 volts with a maximum of 0.5 amps. Okay, so that's kind of important just to kind of keep in the back of your mind. So for our 12 volt, for our 12 volt LEDs, this obviously will not work. So that we cannot use. So now we're back over here. Okay, and this you can see has the output of 12 volts and 3 amps. Okay. And this is really, really important. So if you're out and about, maybe you're at, where I look a lot is Goodwill, Savers. Savers for me is like a secondhand store, and there's quite a few of them around, and they always have gobs and gobs and gobs of these power adapters. And there's this one particular Goodwill that I go to. They too just have stacks and stacks of power adapters. So a lot of times when I need a stack of power adapters, I'll go to those stores because usually they're just $1 or two. They're not terribly expensive, um, and and anyhow, I look for this. Okay, now 3 amp. Let me just tell you generically, if you're making LED signs like you just saw, we're making that Harley May sign. It's 12.5 feet. Now we're going to see here momentarily that a 3 amp power adapter is not going to cut it. Okay, and we're going to go through the calculations and explain why that is. But so really, for the most part, most of what you're going to be looking for are 5 amps, okay, or even bigger, but really your baseline is 5 amps, okay. So what that means to me is we had this $17 kit that came with our power supply. It almost means nothing because this power supply is not even big enough to run this entire strip. And you say, well, why would they include that power adapter with the strip if it's not big enough? Well, I can't tell you. It came from China. I can't tell you why they would. I'm just telling you, as we go through here, you'll see the explanation in more detail why this is the way it is. Okay? So at any rate, that's what you need to look for. You need to look for this sticker, and this is what you really want to focus on. What is the output of that power adapter? Okay, we don't necessarily care what the actual end is. We just need to know what the output of the power adapter is. So in this case, 12 volts, 3 amps. Okay, so there we go on that. Now, let's talk about the math. Okay, so we're going to go to page 1 here, and we're going to kind of break this down step by step. Again, if you want to print this out so you can kind of follow along and put your own numbers in here, we have a separate sheet where you can kind of plug in your numbers, and this will all make more sense to you. Okay, so first of all, we said earlier that 1 meter equals 3.28 feet. So this is how to calculate the power adapter wattage. Okay, so and again, the whole reason I'm going through and understanding calculations is so that I can have all of my calculations automatically calculated for me here in this tool. I know how many feet I have in my design is 12.5 feet. Okay, so I know that, but I want to know what power adapter, how much wattage is 12.5 feet going to use, and what power adapter is going to be required to power this properly. Okay, but I want to be able to click on that button and have all this calculated for me. So I have to understand the formulas behind it all. And so if you don't have this tool, this will help you figure out what your power adapter requirements are. It's really quite easy. So what we want to do is we want to take the output volts, multiply that by the output amps. Most of the time your power adapter is going to show you volts and it's going to show you amps, but it's not going to necessarily specify wattage. So that's what this does. We take the output volts and we multiply that times the output amps, and that gives us the output wattage, the maximum output wattage. So for example, a 12 volt 3 amp power adapter, 12 times 3 equals 36 watts of maximum output. Okay, so we can have 36 watts used up at a maximum. And then a 12 volt 5 amp power adapter, we can have 60 watts of maximum output. Okay, so it's, as a general rule, it's good to overestimate by 20% the required wattage. Now this doesn't make any sense right at the moment, but it will. So basically what we're saying is when you're calculating for your power adapter, we don't want to push the power adapter to the absolute brink of destruction. Okay, so it's kind of like, imagine if you were driving your car at 150 miles an hour, and the tachometer is pegged all the way up to 10, right? Obviously, your car is going to give out because your car is at maximum extreme RPMs. Well, it kind of works the same way with power adapters. We don't want to be in the red constantly, maximum wattage output. So we want to, have a nice cruising speed, but we don't want to be pushing our limits. Okay, so our motor blows up. All right, so that's what we're talking about here. So we're saying to overestimate the required wattage by 20%, to not overuse or task a power supply at the very maximum capacity for an extended period of time. All right, so 10 watts of usage per meter equals 3.05 watts per foot, and this tool is going to give us how many feet our design is, and then it says 10 watts. So the formula is this: 10 watts divided by 3.28 feet, because there's 3.28 feet in a meter. 10 watts of power is what the manufacturer says. 10 watts of power per meter. So that's how we get the 3.048 watts per foot. Okay. So now that we have the 3.048 per foot, so a 12 volt 3 amp power adapter can safely power how many feet of LED strip? That's the next question, because that's the power adapter that we're working with, right? Because that power adapter was 12 volts and 3 amps that came with our LED strip. So how much can that safely power? Well, we know that if we took 12 volts, why are we using 12 volts? Where did 12 volts come from? Well, that's the power adapter. So we got 12 volts times 3 amps equals 36 watts of maximum output. Okay, we talked about that up here. So 36 watts divided by 3.048 watts per foot, which we calculated up here, gives us 11.81 feet of maximum usage in our LED sign. Well, we have 12.5 feet, not 11.8. So we know that 3 amp power adapter is not sufficient enough for our 12.5 feet of sign. Now, here's the other thing. This was maximum wattage. We don't want to be at maximum wattage. Remember, we want to use that 20% rule. So to calculate the safe maximum wattage that we can use, we would have to take the maximum wattage, right? And we're going to divide it by 1.2, because that's 20%. So we're basically taking away 20% from 36 watts of maximum output. That gives us 30 watts of maximum output for safe usage. Okay, so maybe I'll go ahead and change that to maximum output for safe usage. 36 watts, or 30 watts rather. And then we know that if we have, so I'm going to grab my text tool here. If we have 30 divided by 3.048 watts, we know, so I'm going to go ahead and pull up my calculator here. So we'll do 30 divided by 3.048. That gives us 9.85. So let's just call it 9.8 feet of sign rope. That is the maximum that we can have in our sign, 9.8 feet, and stay within that 20% buffer. Okay? So now that we know all the necessary requirements in terms of how to calculate what a given power adapter is capable of, we got the 20% buffer we need to keep in mind. We know how many watts per foot. Now, your LED strip might be something different. It's going to be pretty close, right? It's going to be pretty close, but you would just plug in with whatever your manufacturer says in regards to how many watts per meter or how many watts per foot. There's other ways to calculate how many watts too. We could hook it up to a multimeter. I mean, there's multiple ways to figure out how many watts the LED strip is actually using. But now that we have kind of this basic formula, now we can go ahead and create a tool inside our macro that will calculate the power supply requirements for us automatically. Okay, and so that will be a very helpful addition to this macro. But so right now we know that we have 12.5 feet in this sign. Okay, so we do know that. So so we could take 12.5 times 3.048, because we already calculated that's how many watt per foot. So we are at 38 watts. Okay, so I don't think you'll find a 4 amp power adapter. So it goes 3 to 5. And so we already figured out up here, you take 12 times 5, that gives us 60 watts. Well, we only need 38 watts to power this sign. So 68 or 60 watts is going to be perfect, because that's going to include, that's going to be within our 20% buffer that we're looking for. So we're not maximizing our 5 amp power adapter. So just to kind of go backwards, just to kind of hit home these calculations, we know that a 5 amp power adapter can output 60 watts at maximum. But what is the output wattage with the buffer? So we take 60 is the maximum, we divide that by 1.2, and that's going to give us 50 watts. 50 watts of maximum to stay within that 20% buffer. Well, then how does that translate into maximum length for our sign? Because that sometimes can be helpful. So if we know that we have a 5 amp power adapter, how big can I make my sign and fit within 50 watts? Well, we already know that, because we already calculated the number of watts per foot. So all we have to do is take the 50 watts of maximum output and divide it by 3.048. And so that gives us 50 divided by 3.048. That gives us 16.4 feet for our maximum sign output. So what we could do is back over here. Let's switch back to our sign. So if we wanted to know exactly, how big to make our sign, we could nudge it up. We know we can go up to 16.4, so that's only going to use 13.5 feet. That size is going to use 16 feet. So we could make it just a pinch bigger. 16.5, so that's just a little bit too big. Right? So 16 feet, close enough. So we know we can make it as big as 31 inches wide and fit within that 16.4 feet maximum for a 5 amp power supply. Okay, so if we only have a 3 amp power supply, how big a sign can we do? So we know that for a 3 amp power supply, we have 30 watts that we calculated. So 30 divided by 3.048 equals, we can go to 9.8 feet. So we can go ahead and scale this down until we get to let's see, what did I say it was? Basically 9.8 feet. Yeah. So how big is this one? 11.5 feet. There we go. So we can go up to 18 inches wide for a 3 amp power supply and still be within our buffer. Okay, so this could be very, very useful. So you can be able to size your signs appropriately and make sure that the power adapter is appropriately sized for your sign. Because what will happen is let's say, for example, we made this sign 22 inches. Okay, let's say we did that. So let's go ahead and just change the size of this sign to 22 inches, calculate our length. We're back to 11.5 feet. Okay, so let's go back. 22, we'll calculate that. So we're at 11.5 feet now of rope, which is too much. Um, for our maximum wattage. What that's going to do is either going to prematurely burn out our LEDs, or it's going to prematurely burn out our power adapter because we got the foot on the pedal, maximum gas, maximum RPMs, and that won't last for an extended period of time. So it is important that we get these power adapters lined up just perfectly so we're not underpowering our projects. So I hope that helps you figure your project out a little bit better. And we're going to be able to have all these calculations within our little macro here. So going forward, we'll just be able to click a button and know exactly the required power adapters for any given design that we're going to be making. Alright, so I wanted to do a quick little addendum to this video in regards to power and show you something that I just recently got in, and I really didn't think this all the way through. So this is a power adapter that you can change the voltage on. And you can see the model number, and you see the output there where it says 3 to 24 volts. So I thought this could be useful, and I probably am going to keep this because I have some filament LEDs coming in that are low voltage. And I don't have a power adapter for a 3 volt power adapter, so I may still keep this. But I just want to point out, it says right here, please note the maximum output current is 1.5 amps or 1500 milliamps at each voltage setting. So what did we learn earlier when we were talking about, well, how do we calculate maximum wattage? What I was looking at, it says the adapter does not work with devices over 36 watts. But I didn't really think about the fact that it was only going to do 1.5 amps per voltage setting. So if we take 12 and we multiply that times 1.5, we know that that is only going to give us 18 watts. Well, we know that 18 watts in regards to LED strips, if we are using 10 watts per meter, is only going to give us maybe 6 foot lengths of neon rope that we could power at a maximum by this power adapter. Now, like I said, I didn't really buy the power adapter to use with LED signs. I bought this power adapter primarily just to test with. So for testing purposes, this will work just fine because we're only going to be testing, strips of LED light to see if they're soldered properly and things of that nature. So that's really why I bought this power supply. And then also, if I have 5 volt LED strips or 24 volt LED strips, I can use the same power adapter for testing purposes for all of them. And it will also work with the little LED filament that I have coming. Okay, so just keep that in mind. If you are using an adjustable power adapter here, that you keep in mind that the amp setting is at for each voltage setting, and that for example, we're not going to get 36 watts at 12 volts. We'll get 36 watts at 24 volts because 24 times 1.5 is in fact 36. So that's how that works. Okay, so hopefully you find that also useful information. As long as we're talking about power adapters, I thought I would show you 2 additional products that could be quite useful in powering LEDs. So this is a device that you can plug into a standard USB port, and it will convert the standard 5 volts that comes out of a USB port and convert it to a voltage that we can use to power LEDs. So you can see the output value is a half a volt all the way up to 30 volts. But the maximum current limit is 2 amps. So 2 amps at basically 2 amps at each uh, voltage setting. So for example, in regards to 12 volts, so our most typical LED strip is a 12 volt strip. Okay, so at 2 amps, the most output wattage at 12 volts is going to be 24. Okay, so we take our voltage times our amperage, gives us our wattage, so we're looking at 24 watts. Well, earlier we learned that each meter of our LED strip consumes 10 watts of power. So what that means for us is that we can power approximately 6.5 foot of LED strip with using this adapter. Okay, um, so obviously 6.5 foot isn't going to be all that useful for powering an entire LED sign, but where I intend to use this is an option to test individual lengths of LED strip. So, most of your lengths in your LED signs might only be 2 or 3 foot long at most. Most of them are shorter than that. So this will allow us to test those individual strips without being plugged into the wall. So that's why I bought this. We can connect our positive and negative power leads here, and then we can test little individual pieces of LED strip. So that could be a useful option for you. So I do want to show you one other thing, and they make them for Milwaukee and DeWalt, and this particular one is a Ryobi version. I have Ryobi power tools, and this will take an 18 volt battery, Ryobi battery, and convert it to have 12 volts of output. Now this guy here, it can push out some watts. So if you look here, it says that the 12 volts of output will give us a maximum output power of 15 amps. Okay, so so if we come in here and we take 12 and we multiply that times 15, that gives us 180 watts of output, which that's pretty significant. So where this is most commonly used is in like the power wheels. Sometimes the batteries go bad in those power wheels, and where this way you could just take your Ryobi battery, power your power wheel, and just keep. I don't know, I probably have 15 or 20 of these batteries for all my different tools. I've got a bunch of these batteries. So we could just swap them out, constantly swap them out, swap them out. My little girl has a little Power Wheels Jeep, but her little battery, only lasts so long. So this, I can just switch out the wiring, pop in a new battery, and she's good to go again. So she could drive all day and never stop with all the batteries I have. So this can be quite a useful device. But for the purposes of LED, this could be really useful. So when we're talking about LED strips, we can we can connect basically three 16-foot LED strips. So each LED strip typically is 5 meters. And each one of those strips are going to use approximately 60 watts of power. So this has a 180 watts output maximum. So we could, in theory, connect 3 LED power strips to this. And now I don't know how long the battery would last if we were to connect 3 LED strips. But if, let's say, we were doing like a trade show or something like that, and we had a standard 10 by 10 tent, well, you could easily wrap 2 LED strips all the way around the tent, and for sure that would give you quite a bit of lighting and would not max out our wattage here for our Ryobi battery. So you can see they're pretty inexpensive, so you could definitely get some really nice lighting effects with those LED power strips for your outdoor events and things like that. So this could be very useful in a variety of applications. But this does have a nice um, significant output. So we could use it to power an LED sign at an event, uh, or we could use it for ambient lighting or whatever. So that's really it on what I got for you on power adapters and power for LED strips. I hope you found the information useful, and thanks for watching.